Hi there. Hey, greetings. Hello. Okie dokie. Lesson 68. Be taking notes. There aren't a whole lot of notes here, and I'll go through maybe 3 examples, and then you're gonna have to figure it out yourself. Okay. So today we're gonna talk about conditional probability. That is, we've got 2 dependent events. The second thing depended on what happened in the first one. And the way that we're going to say these when we write it as P of B slash A, B line A, is the probability of B given that A has occurred. We'll talk about spinners. We'll talk about some, they're going to do a lot of this kind of thing when you get to your homework, these charts, and you're picking out what parts that you need given that something else is also true. So there we go. The probability of B given that A has occurred. So of course B comes after A has to happen, and then B, the probabilities might be different, or we're going to combine the 2 things. So this is the formal way of writing these things. So you know, in conditional probabilities, you want to find the probability of A and B happening. You find the probability of A, just like normal, and then you're going to find the probability of B given that A occurred. You need an example. So let's go to spinning the spinner. Okay, we'll have here will be event A, and that is lands on 2. And then we'll have spinner B here, or event B, which is sum of 6. And we're going to follow this rule right here to calculate the probability of this situation here. So let's start with the probability of A. What's the probability of A landing on the 2? There's 1, 2 out of 4 pieces. Probability of A is 1 out of 4. And then we're going to multiply that by the probability of B given A. Sum of 6. Well, there's lots of different ways of getting 6, right? Am I right? You could have 2, 4. You could have 3, 3. And you could have 4, 2. But the only one of those that sum of 6 given that we landed on a 2 first is if we land on a 4. So getting 2, 4 is the only one way of the different ways to roll first and then roll the second one and get that total. Right? Right. So if you're looking in the book, the very first example, out of the total ways there of doing it, probability A and probability B, blah, blah, blah. Of all the possible combos of 1, 1, 1, 2, 1, 3, 1, 4, 2, 1, 2, 2, 2, 3, 2, 4, 3, 1, 3, 2, 3, 3, 3, 4, 4, 1, 4, 2, 4, 3, 4, 4, we're going to get only one of the 16 that fits this. Okay, there are lots of different ways to get a sum of 6, but only one way given that it landed on 2 first. So, of the total ways altogether, getting that sum, or getting any sum, I guess we should say, 1/16 is lands on 2 first, and then has a sum of 6 second. Okay, they've got a big chart. I was like, man, that's a lot of thinking. Let's just, and their chart is similar to the things that we have for rolling dice. It's just specific to 4 slot spinny thing. Spinny chair. Spinny chair. Okay, so that's the only one of the 16 ways that actually fits both of the conditions. Second would be one of these types of charts. And I don't always use this process here of finding the answer. I'm going to use just kind of like my brain, I guess. So example 2, table shows the results of surveys that ask students to state the year and season of their birthday. Obviously, this is kind of old because those people would be in their 20s now, and you guys are not. So anyway, first, we're supposed to find the probability that somebody's birthday is in the winter given that they were born in 1993. That's what the thing says. Find P of winter slash 1993. Okay? Given that. So that means that first thing that we have to do is we look at 1993. So we got this right here. Probability of the thing. Probability of B given that A has occurred. So we're looking at, okay, everybody that's in 1993. We're going to take the number of people that their birthdays are in the winter that happen to also be born in 1993. Okay? Winter, and then all the people there. So I'm just going to kind of like do this circle-wise. I got all of these. That's going to be the bottom part. 16 plus 9 plus 11 plus 9. And then we got the winter people. Winter, but they have to be born in there. So we got, of those, we got the 16 of them. So what do we got? We got 16 out of 20, 36, 45. Is that right? This is 45 people there. 20, 30, 45. Yeah. And there you go. As that comes out into a percentage probability that you were born in winter and given that your birthday is in 1993, it's about 35.5%. Yes, that corresponds to what they've got there. The second one is flipped around, and now they say for part 2, you're going to get that. Now we're giving the probability that you're born in 1992 given that your birthday is in the winter, spring or summer. Spring or summer. Okay, given that. So first we think about, okay, well, what are the spring and summer birthdays? Those are all these birthdays right here. And now we're thinking about then, of those, which ones are in 1992? It would be just these two. So we add up 6 and 12 and 9 and 11 and 11 and 8. We add up all these spring and summer birthdays. And then we're like, wait, but you have to be born in 1992. So let's only take those ones from the spring and from the summer. Okay, so that's pretty quick. We've got 18. We've got down here, we've got, there's 20. There's 32, 40, 51, 51, 57, 1857s, which boils down to 31.6-ish% when we're all done. I kind of like this better. I think if you want to use pencil in your book and circle them this way, we have to consider first the A thing, and then we consider the B thing, right? B given A. Probability of B given that A is occurred. So we consider A first, all the spring, summers, and then we look at how many fit in the B category of those, and that goes on the top. There's one more that we'll do, and it has to do with like a raffle or something like that. Let me clear the board, and then we'll get that up. Okay, we've got our situation here. We got juniors and seniors, and they're gonna have a raffle, and they're gonna give away some prizes. First prize is, I don't know, a new iPhone. Second will be something else really cool, a Rubik's Cube. And third prize is just about as good, would be a burrito from your favorite place to eat. And they're asking what is the probability that the prizes go to a junior, and a senior. All right? And it has to be in that order. So it's like given that, given that. So first, we've got to figure out how many people there are all together for starters. So we add up these two. We got 12, 1190, 1205. There's 1205 total amazing high schoolers here. And the iPhone going to a junior has a probability of 587 out of 1205 peoples. Now that that junior has got the prize and we want to give that next Rubik's Cube to the next person, there's only 586 juniors left to pick from of the 1204 people that are left. And then thirdly, that burrito, the one that I would really hope for, seniors, now there's still 618 seniors left who haven't got a prize, but there's only 1,203 people left. Let's multiply all those together, and our calculators will give us some type of something or other. It probably won't give us a fraction anymore. 587 over 1205 times 586 over 1204 times 618 now, because we're dealing with seniors, over 1203. And I get that the chances are that happening in that particular order about 12.2%. About 12.2%. So the formal way of doing it sometimes gets a little clunky, but if you can write on the thing, or you can just walk through the thought process, you'll be figuring out these conditional probabilities, I think, pretty quickly. So use a table. You can either make a table like they did in 1 or in 4, those examples in 1 and 4, or they might give you a table and I'd say feel free to draw on it and then erase it when you're done. Or take a picture and then draw on that. I don't know. So there you go. Conditional probability. We'll talk to you hopefully when it's math chat time. Math chat time. Bye.